All right, so this video we're going to continue with the GARCH model and how to test, how to do an hypothesis test for it. So in general, we get the GARCH PEQ. Again, this is just an autoregressive moving average of the residuals. And then also typically, usually a GARCH 1-1 is sufficient, but we'll go ahead and do it for the general model just so you'll be prepared to do it. So our variance of today is going to be equal to our W plus our alpha terms. So alpha 1 with 1 lag for our error term square plus all the way to alpha P. I'm sorry, alpha Q. Q is in the error terms, just like the ARMA. So T minus Q. So Q many lags in the error term squared, then plus our beta 1 multiplied by the previous value of our variance plus all the way to P, beta P of P many lags of our variance. So testing for GARCH, you estimate a model for your, for let's say Y, so you estimate some model for your Y, and then you compute the autocorrelations. You compute the autocorrelations of the error squares. Then you're going to use a Box test. So to compute an autocorrelation of the error term, we use let's use rho K for that specific lag. It's going to be the covariance from K plus 1 all the way to T, many observations, cap T, many observations. And this is going to be the error term squared minus our estimate for for the variance. This is just like the autocorrelation for the ARMA model, except it's focused on the second one instead of the first. Whereas for the ARMA, you were dealing with your estimate for Y. Now we're dealing with our estimate for variance. So then you're going to have K many lags, or K lags squared minus, again, your estimate for that and all of that divided by from T equal 1 to cap T, or cap T many observations. You're going to have the error term squared minus again, your estimate for variance. This is going to be squared. This is really going to be the variance. Then the test for this, you're going to use a Box test. So the null hypothesis, remember the equality is always on the null hypothesis. So for a GARCH 1-1, you're going to say that all your alpha and your beta is going to be equal to 0. You're assuming that there is no heteroscedasticity and that it's constant. If there's constant, if it's homoscedastic, then that would mean that the variance would just be equal to the intercept, and the previous values doesn't matter because it's not conditionally heteroscedastic on previous values. It's just homoscedastic. So no hypothesis is a constant variance. Then the alternative hypothesis be that either alpha or beta is greater than 0. Then in order to use this, in order to do the Box test, you're going to use a Q statistic. So Q statistic is going to be equal to cap T many observations multiplied by cap T plus 2 multiplied by from I to 1 to K many lags, all of the K many autocorrelations squared divided by cap T minus I for that I flag. And this Q statistic is going to follow a chi-square distribution. And again, K K is number of lags being tested, is equal to number of lags being tested. So this is it for GARCH and ARCH. And then for these models, remember back from last semester, we went over briefly value at risk. You should have gone over that in some of your other classes as well. So you can use GARCH and ARCH, these volatility models, to have better estimates for future volatility. So you can have better estimates for value at risk or expected shortfall. You can also have you can plug it into in some of the asset pricing models. You can use it for to value options or applications such as that. So this is it for GARCH. In the next set of videos, we'll cover the adaptive asset allocation model, and we'll go over the stock to flow Bitcoin valuation model. So that's it for this video.